Hello everybody, and welcome to this session on test-driven development for SharePoint and Office 365. My name's Bill Ayres. Those of you who know me well will know I don't normally talk with this deeper voice, so for some reason I've got some sort of throat infection causing a little bit of discomfort, but it's also had the rather pleasant side effect that it means I can do quite a reasonable Roger Moore impersonation. So the name's Ayres, Bill Ayres, and I'm an MCM, MCSM Charter SharePoint. I also have a bunch of other qualifications, and I do mainly consultancy around SharePoint and Office 365 development and architecture. I also do some mobile development as well. I also work with Scrum teams. I've got a PSM1 qualification for that as well. So there's my contact details. If you'd like to get in touch with me afterwards, I'd be very happy to answer your questions if I can. So this session is a sort of a follow-on from one I did at SP24. We did about a year and a half ago. And there I talked about agile development as a whole and lean, and in this session we're going to focus down specifically on test-driven development, and we're going to look at some server-side tests, obviously, because that's still a part of SharePoint development, but we're also going to look at what for us is the relatively new world of client-side development and how we can do testing do client-side tests. Then if I've got a bit of time at the end, we'll talk a little bit about acceptance test-driven development and approvals tests and some of those techniques, and then we'll wrap up with some conclusions. So what is test-driven development? Well, it's really started with test first, and I think we have to give credit to Kent Beck for this, who introduced it as part of XP, which is Extreme Programming, which was one of a number of agile development methodologies that came out over the last 20 years. I don't think XP is quite so popular nowadays as it was at the turn of the century. It seems to have lost a little bit of the traction that it had at one stage. Other agile techniques seem to have taken over, but what was important about XP is it introduces a lot of the agile techniques that we use, things like pair programming and test-driven or test-first development. So test-driven development really takes it a step beyond test-first. Test-first is doing your testing before or building your tests before you build the production code, as opposed to the old way we used to do development, which was we'd build our production code with the intention of probably coming back later and building some regression tests around it, and we usually never got around to doing it. So test first forces you to build the tests before you do the production code, and test-driven development takes that one level further and says that the tests are really what is going to drive the low-level design of your code. And to some extent the tests then support documentation of the code. They become almost code documentation and replace what we used to do. If you remember, people who have been doing development for a while will probably remember writing 600-page detailed design documents for capturing the low-level design of code. So tests can kind of do that for us as well. The tests support refactoring, so we automatically get a set of regression tests as we go, and that gives us the confidence to do refactoring. Refactoring means rewriting our code to improve it, either in terms of its code quality, readability, maintainability, perhaps performance, but without changing the behavior of the code. Some people mix up refactoring with just rewriting. It's not just rewriting code, it's specifically changing the code without changing its behavior. But the important thing to remember about TDD is it is just a developer tool. It's not a way of life, it's not a religion, it's not a lifestyle choice. It's simply a tool that we use to make development easier and more productive, and ultimately to produce better quality code, which usually translates into lower cost of development and maintenance. So the TDD cycle. We're going to start with some requirements, a list of requirements, or perhaps like acceptance criteria, and we work through those, and we take one, and the first thing we do is we write a failing test. It's very important that we write a failing test, because that enables us to be confident that we've written a test that tests something. And then the next step is to make that test pass any way we can, and in fact we do it the simplest way possible. Then there's another step which is sort of optional, which is to then refactor our code and make it better. The first version that passes probably isn't very good quality code, but by the time we finish refactoring, it will be good quality code. And then we go back and we write another failing test. We go around this loop another number of times until we've written all the failing tests that we can think of for that requirement, and then we go back and we take another requirement and we write a failing test and start the process again. So we're going round and round this loop, which is often called red-green refactor, because the test running tool, whatever it is, perhaps Visual Studio or a tool like NUnit, will show a green or a red depending on whether all the tests have passed or whether one or more tests have failed. So we'll go around this loop, and this is the smallest cycle in the whole of the agile process, so this has to flip around very fast, and that's the reason why tests have to run fast, of the order of a few seconds. So over time, as we do all this, gradually the design of our code will emerge, and it will be good code, because at each step as we go around we do this refactoring. Now there's a few rules that we have to follow. One of the rules is that we're not allowed to write any code unless we've got an actual failing test. So you can't, for example, write a bunch of code in anticipation of what you might think you might want or need later. You have to write the failing test first, and this forces you to have test coverage. You're only allowed to write just enough code to pass the test, so you can't sort of again anticipate something that you might need later, and you just have to wait until you've written a failing test to do that. And you're not allowed to write another test until the existing one is green, so all the tests are currently passing. So you can't stack up a bunch of tests ready for future use and sort of pick them off, make them turn green one by one. Now you might want to use some sort of aide-memoire, such as writing some tests and commenting them out in your code. That's perfectly permissible, but we don't make them active until we're ready to write the production code. And then refactoring, we define refactoring, it's not changing the behavior, so you're not allowed to add new functionality as part of that refactoring step. To make all this work, the tests obviously must be very fast, so they need to run quickly in the order of seconds, and they need to be easy to run, so that implies we need an automated testing process, so you need to click a button and they all run. We want to make the purpose of the tests clear so that they kind of document the code that we're writing, and we want them to be independent of each other so that you don't have to run them in a certain order. So one of the bad signs is that when you have a set of tests that alternate runs, they either pass or fail, which usually means there's some sort of interdependency between one or more tests in your collection of tests. And our test code is a first-class citizen, so we write good quality code, as good as we write production code, so we don't write sloppy, badly written test code. So how does TDD work? Well, it's not obvious, and probably what happens is that the tests, because they enable you to do refactoring, they free you to improve the quality of the code and fix the things and stop that awful situation where over time the code rots because people can't make changes to it for fear of breaking something, and so things that ought to be improved just get left the same, and the code gets bigger and bigger and uglier and more difficult to maintain. And I think this is really the key gain, is that it stops that from happening. It allows you to do incremental design. So when you first come up with a design for your code, and we're talking about low-level code here, although it can also apply to the architecture as a whole, but particularly at the low level, when you design your code, it's often not the optimum design, and you only realize later, after you've built it, that there's a better way of doing something. If you use this approach, you've got the protection of the regression tests that mean that you can make those changes and improve the design without having the fear that you're going to break something and it's going to be too expensive to fix. So it makes it economical to improve the quality of the code and gradually change the design over time so that it in increments approaches a more optimal low-level design. Failing tests also are very good at finding your errors, particularly as they usually fail immediately after you make the mistake. So you just know straight away what the problem was, and certainly the longer the time period between when you made the mistake and when you discover it, the more likely that, or the easier it is to fix the error. And the tests also, if they're written well, will isolate the code that they apply to. So they will, when you get a failing test, it kind of pinpoints where the problem is and gives you very quick feedback on where your errors are. So that's probably in combination, all those things are what makes TDD so effective, even though on the face of it it looks as though it should be causing you more work. Many benefits, apart from better code quality. It also helps you apply some of the lean principles and agile principles like KISS, keep it simple, and YAGNI, you ain't gonna need it. So there's this tendency to build things against some perceived possible future requirement because we know it'll be expensive to come back to this piece of code later, so let's just put this thing in now while we're here, and that ends up with creating excessively complicated solutions that anticipate requirements that might never actually arise. But if you've got the confidence that you can come back and change the code later, you might adopt a simpler design, knowing that you can always add additional complexity at a later date. And to some extent the tests are your documentation as well, which makes it easier to make the maintenance of the code. So if you come along later and you want to do some more development, or you're not the original developer, it's going to make it, having that set of tests is not only giving you the regression suite that protects you from breaking something, but it also tells you what the code is supposed to do, and in some cases why. And it allows you to do incremental development as well, so you can come back to some code and extend it later much more easily than if you didn't have that level of robustness and protection that the tests provide. So one of the things I've found is that if you're very vulnerable, as I am, to interruptions, such as somebody tapping you on the shoulder, or the phone ringing, or two people talking loudly nearby, which I find it almost impossible not to listen to what they're saying, then this is a good way of getting yourself back on track, because if you've got a failing test, it's pretty obvious what you need to do next to fix it, and it gets you back into the groove of getting back developing again. And I actually find that once I get going, I can get into the sort of that rather satisfactory development trance that you can sometimes get into when you've really got a good development flow going, and using TDD helps me get there faster. Refactoring is all about removing duplication, making the code more compact. There's nothing more satisfying than taking 1,000 lines of badly written code and turning it into 100 lines of very neat and easy to follow code. And that's something you can safely do if you just keep everything, all the tests green. You can gradually whittle away at those annoying bits of ugly code and improve them over time. You might do all kinds of refactorings and improving the structure of the code, making variable names more readable, and if at any time anything goes wrong, well, you can just back out those changes. Particularly if you use it with source control and do frequent check-ins, you can very quickly get back to your passing state, get from red back to green. So an example of a user story, this is in most agile methodologies, you have some kind of user story. In the old days, well, not that old, we used to have requirements documents, and then we started using perhaps UML modeling and various techniques. This is really a very stripped down, very simple way of capturing a requirement, and the story, user story, says something like the bits in bold are fixed, so you say as a, and then the person who wants the feature, I want, and then the name of the feature, something that describes the feature that there's the requirement, then so that the justification for it. And that last one is quite important because it makes the business analyst or the product owner think about why they want a feature, and it also communicates to the developers why that feature is wanted, which somehow is really helpful when you've got a development team. And then you'll have some acceptance criteria, and they might form a series of questions or statements. In this case, we've come up with this rather contrived example of the analyst has decided that or the business owner has decided they want a shopping list to appear on the home page of their, what looks like their 2007 SharePoint site. You'll notice how the first acceptance criterion is, does a shopping list panel appear on the home page? Now we'll probably implement that as a web part, or if we might do it client side, and we might use some other approach, such as using some sort of add-in. But you'll notice that the requirement doesn't say which one that's going to be. And in the example that follows, I'm going to first of all do it as a server side and then client side. And then it'll gradually, this list will probably be quite a bit longer as you think about the problem and refine the list of acceptance criteria. So let's take a look at an example of doing something like that and see how that works. So we have this shopping list in SharePoint. So we have a SharePoint list, and I've already created that. It's got the list of items. And then what we're going to do is we're going to open Visual Studio, and this is just a normal version of Visual Studio 2013. I think this is the professional version, so it's the pretty standard version, and we're creating a visual web part. So if you remember, a visual web part is like a user control in ASP.NET. And then what we can do is we can look at the ASCX page, so there's a markup page associated with that, and if we were to try to deploy that into our SharePoint instance, then we've got quite a long wait while it recycles app pools and uploads it and so on and installs it, and that's just not acceptable for any kind of test-driven development. So clearly we need to find another way of testing this web part. So I've got this second project here called unit tests, and I've created a test class, a shopping list test.cs, and that's actually, you can see that the class is actually derived from the web part. So the shopping list test is derived from shopping list web part. And in fact, you can use any class you like to create a test class. It doesn't have to be any particular type of class, as long as you decorate the methods with these test methods and test initialize. And if you look at the test initialize method, you can see that I've created a string writer, which I've then used to create an HTML text writer. And I've used that, so I've then called the various methods of the web part, including render contents, and output that to the string writer, to the text writer, and then captured that content that the web part has rendered in that string called content. And once it's done that, and the initializers class has done that, we can then run various tests against that content string variable. So that's what we're doing here. We're creating our first test, and it's testing that the content contains H1 shopping list, which of course it doesn't because we haven't implemented anything yet, so the test goes red. So this is our first failing test that we've created against our requirements, against our acceptance criteria. And what we're going to do now is do a very simple implementation. So I'm editing ASCX, shopping list web part ASCX, and adding shopping list and making it an H2 element, and I'm doing that in the sort of WYSIWYG editor. But if you also go over to the source, you can see that it's created an H1 element in there. So now if we run our tests again, we would expect that the test would pass. So I'll do run test. There are various ways of running it. So we're using MS Test, the built into Visual Studio, and the test runner goes green. You see the green bar in the Test Explorer panel. So the test has passed and we're at green. Now we could refactor, but there's not much that we need to refactor, so we move on to and create another failing test. So now we've created an unordered list, and we need to implement that. So we're back to red, so we implement that again by simply doing the simplest thing we can, which is just add an unordered list, and we would expect that test to pass. And this is a little bit of a contrived example, obviously, to make it simple to demonstrate. Your algorithms might be more complicated that you're testing. And that goes to green, so that's a pass. And then we can continue, so we'll create another test. This time we're looking for the string bananas in a list element. That's going to fail, of course. And then we go in and we again create the simplest bit of code that's going to pass the test, which is going to be to just manually type in here a list element with the word bananas in. Run our tests, and for the third time we're back round to green. So far so good. So let's just keep going for a little bit longer. Humour me, we're going to add another test. And this time we're going to look for another string, which is cereal. And of course that fails. And we go back into the source code. You see how the test runner indicates what the comparison is, which test failed and why. So we type in cereal in the shopping list. And then we run the test runner again, expecting green, but it's still red. But if you look at the test that's failed, it's a different test to what we had before, which was the one that we set this up for. So we've got a regression test here because we made the mistake of, in adding cereal, we deleted bananas, which was one of the earlier tests that we satisfied. So we have to fix that, and then we're back to green. So as we go on building up tests, then all of these tests are running each time. So we're building up a set of regression tests as we go. Now you might have noticed that we talked about implementing it in the simplest way possible. We probably want to aim a little bit higher than just simply typing in our shopping list. We want to actually render the contents of the list. So we've got a repository class, and we can bind the data to this repeater element. So now whatever is in the repository class will get rendered into the web part, and we've made a change. So really nothing's functionally changed here in terms of behavior, but the output is the same. But we've made an important change to the code, and we've verified that it's still green, so it still passes. So here's a few quick hints and tips. I mean, one of the things to be aware of is writing meaningless tests. You know, the tests should do something that could potentially fail, and we didn't really follow that rule very accurately in the example, but we were just trying to do something as simple as possible to show you. But you just got to be a little bit careful. You can create a bit of a false sense of security if you provide loads and loads of tests that just do things like check that the string library concatenates two strings correctly. You know, that's not really a useful thing to test, because we're pretty sure that the string library is going to work. I think a nice analogy for these tests is one that Kent Beck gave, which is that they're like the pitons when you're climbing, and you're driving them in as you climb up, so that if you fall off, you don't fall very far. And you can think of the tests as working like that, and potentially also think of them as a design tool that's helping drive the design, the low-level design, just let that emerge by itself, and rather than overthinking the design, because you can always go back and change it and refactor it, so you always able to sort of keep iterating the design until it becomes optimum. Now, not everybody is going to buy into TDD, and if you've got management who are skeptical, you might well encounter a conversation like this one.
Hi, I'm your software development manager.
Yes, I am the SharePoint developer.
What's this I hear about you wanting to do test-driven development?
We plan to use test-driven development to make our software development process more efficient.
Doesn't that mean you have to write lots of code now?
Yes.
Well, that is a really stupid idea. It will take twice as long. Duh.
Yes, but once we get good at it, we will have better software quality.
Software quality is not a problem. I have an offshore team of testers to catch all your bugs.
But by the time the offshore test team find the bugs, we have moved on to something else.
That's okay. The development team can work weekends to catch up.
It's not always easy, so there might well be a situation where the pressure's on and the test-driven development goes out the window, and that can happen when a deadline approaches and everybody starts working weekends or something like that, and the first thing to go is the TDD discipline, which is a shame, because that's often the time when you probably need it the most. If you've got a existing code, it can be difficult to start doing test-driven development because there's so much existing code that's been written without using the TDD approach, and there's no regression test coverage of that legacy code. That can be a problem. There are a few techniques you can use to build tests for legacy code. One of them is the approvals test, which is a test which will take the entire state of some output and just stamp it as the approved version of the output without having to write very granular tests. And that can be something that can make it a bit easier to test legacy code and existing code. That is a challenge. You might not have full management support. Another danger is the sort of very trivial tests and producing large numbers of tests that don't really test anything and give a false sense of security. And not everything is suited to test-driven development, so if you're doing a development spike, for example, it's probably not a good candidate for doing test-driven development. And I don't think anybody would, but you certainly shouldn't regard it as a silver bullet that's going to solve everything. If you've got fundamental problems in your project, then just adopting test-driven development probably isn't going to solve them. And not all code is easy to test, let's be honest, and SharePoint probably comes into that category. Now, test-driven development is using unit tests as opposed to some of these other types of tests, such as performance tests or UI tests, which are the sort of tests that a quality assurance person might do for acceptance tests. They might well do a UI test where they test end-to-end and run against the user interface of the SharePoint site. Those tests are typically quite slow, and there might be a test suite of an acceptance test suite that might take an hour or two to run overnight, which is absolutely fine, but is completely useless for test-driven development. TDD tests have to run fast. Now, unit tests usually run fast. It might be possible to use integration tests, because as long as you can make them work fast, then they are suitable for test-driven development, and that's one approach we can consider. One of the other approaches is to use some sort of repository class or a repository pattern where we isolate the calls to SharePoint and wrap them inside some other class. And I've done something similar to that in that test example. A lot of people use quite elaborate composite patterns where they'll divide everything into the model view presenter pattern, which is one approach. So one of the dangers with this approach is you can end up with this rather trivial test anti-pattern where you've got a model view presenter, you've got separate classes, that all looks very reasonable. You've got a presenter class, a view class, and then you've got a test class that's running some tests against your presenter class, which is fine. That's good separation of concerns. It's good coding practice if you've got a significant amount of logic to isolate in that presenter class, and then the test method will run against that logic. But if you look very closely at this slightly contrived example, you can see that although everything looks quite reasonable, in practice what's happening is the test class is simply verifying that the compiled code is able to concatenate two strings. And that's not very useful because we already knew that the compiler works and we can concatenate strings. So the danger here is you get a large number of classes, lots of tests, and all the tests give you a false sense of security. The tests don't really add any value to the solution. They're not really giving you any additional confidence in you not having caused any regression errors because the tests don't test anything significant. So another approach is to use lots of mocking frameworks. There are only a few that are actually capable of acting as an isolation layer for the SharePoint object model. One of them is Type Mock Isolator. Another one is from Microsoft Fakes, which comes with the more expensive SKUs of Visual Studio. Or you could conceivably build your own fake SharePoint framework purely for testing purposes, and I've tried doing that myself. It's turned out to be too difficult, it's too complicated, too much to do. Microsoft also tried to do that, and I think they probably ended up coming to the same conclusion. So it's not a realistic thing to do. What you might be able to do is mock in an ad hoc basis, mock a particular list, for example, if it has some, create a business object or a repository class around a SharePoint artifact of some kind, and that can then be faked in either using a tool like a mocking framework or using ad hoc fake classes to achieve it, and we'll see that in the example in a moment. But one of the problems is when we're SharePoint developers, we don't really know what's happening exactly beneath the surface, and so we can't always predict what the framework is going to do. So our custom code is really just the tip of the iceberg. We've got the SharePoint.net managed code beneath that. Beneath that we've got a lot of unmanaged code. We've got COM objects, and we've got the ASP.NET and the operating system, SQL Server. So all these things are difficult to predict exactly how they're going to behave. So there is a case for actually running against a real instance of SharePoint, perhaps a version running locally for test purposes with test data, but an actual SharePoint instance, which means that we can't technically say that they're unit tests. We could say that they're sort of very shallow integration tests. One of my friends calls them unigration tests, which I think is quite a good name for it. So we're doing tests that run against SharePoint, but we can use those for test-driven development provided they are fast enough. So we need to make sure that that's probably running on a local instance of SharePoint, and if we can make those run fast enough, then we've got a viable way of doing test-driven development without compromising and having to spend a lot of time writing mocking frameworks when we're not quite sure whether they're correctly modeling the SharePoint instance that they're eventually going to replace. So now if we go back to our project, and you can see that the tests run very fast, suspiciously fast in fact, if you were thinking that they were running against SharePoint. But of course I cheated, because what I didn't tell you was that I was injecting a fake shopping list repository here. So this is actually a technique called dependency injection or inversion of control, but not using some high-end language. I've created a fake object here which returns the list of objects, and I'm would normally, in the shopping list web part, we would assign the repository variable to a normal shopping list repository, but what we did is in the test initialization we assigned it to the fake shopping list repository instead. Now in this second set of tests, which is called the integration tests, we don't do that. We let it create a proper shopping list repository which will actually call SharePoint. So they were true unit tests that we were doing before, which is why they were so fast. And if we run the integration tests, you can see that they run quite a bit slower. There's quite a noticeable delay. Most of them run pretty fast because once we've got that content rendered, then most of our work is done. So the content rendering, whichever test, which in this case is the shows heading test, is picking up the content, then that's got a 1 second time, and the rest are relatively fast because they're not making any further calls to SharePoint. So that's the penalty we pay for calling SharePoint, is a 1 second delay. Now for test-driven development, I think that's acceptable, and we can use that. So we can use test-driven development while working against an actual instance of SharePoint, perhaps not our production instance, obviously. Now you just have to be a little bit careful that you set it to x64 mode when you create your test project if you want to run against the actual SharePoint binaries rather than against some kind of fake object that we did with our unit tests. So we've got the shopping list web part, the unit tests and the integration tests, and if we go to the shopping list web part and now deploy it for the first time actually into SharePoint, and then we go into our page and we edit the page, and we're going to insert a web part, and the web part will be custom shopping list. So this is the web part we've just created, never run it before inside SharePoint, and sure enough when we render it and when we save it, it renders as we intended it to render. So just when we thought we'd got to the bottom of server-side testing, along comes a new model for SharePoint development, which is not just add-ins, not just the add-in model, or used to be called the app model, but the whole notion of doing our development work off server somewhere else, either on the client side in the browser, perhaps on a mobile device, or on some external server using possibly some other technology like ASP.NET MVC or Node.js. That gives us a new set of problems, and certainly with JavaScript we now have the problem of doing our testing inside of the JavaScript that we're writing on the client side. That actually in some ways has made our job a little bit easier, because first of all we have some well-established patterns. Again, we talked a little bit about model view presenter in the context of server-side development. Well, we also have patterns obviously in client-side development. We can do it there as well, and it actually makes quite a lot of sense if you're building something that looks like a client-side application, a single-page application. Probably want to keep your view, which is effectively going to be HTML5, and your view model and your model, which is going to be something written in JavaScript, and keep those separate. And there are a number of composite design patterns for doing this kind of thing, and a popular one which is a sort of a reflection of what we do if we do C# and XAML, and use those technologies for building things like Windows applications. We can use the same sort of approach and using data binding and various frameworks in JavaScript that help us do that, like Knockout, and also that's an element of the Angular framework as well, where the view model are connected by data binding, and then the model is an encapsulation of what's going on the back end, in our case in SharePoint. And we're communicating, the model is effectively communicating using REST or CSOM or the Office 365 API with the back-end system. And that gives us a convenient point where we can inject results, so that if we want to isolate, we can do either tests purely against the view model, or we can also do something where we inject the response that we would have got through REST, say, and substitute some known response for the testing of the whole of that client-side piece, which makes quite a nice model for the isolation of the code that's under test. So there are a number of tools, as you'd expect. Being JavaScript, there's 1,001 ways or libraries available to do this that various people have created, and I won't go through all of these, but I just mentioned that Jasmine is quite popular. It uses this BDD, behavior driven design kind of style of testing. I'm actually preferring at the moment to use QUnit, purely because it uses more of a traditional style of assertion library and style of coding, which is a bit closer to what we were doing in the earlier examples with MS Test. So that's the one I've used in my examples. And in order to use QUnit, we're going to be writing some tests using there. It's not totally different from the way we were using MS Test earlier. One of the big advantages is that the name of the test is simply a string, and then we do some setting up of the test and then some kind of assertion. The one in the example here is an equal assertion, looking for the equality between two values. There are a few others. For OK, for example, we might be looking for the existence of one string inside another, just simply looking for an expected string and comparing it with the actual string in the test. So let's look at QUnit in action. So now we have the client test version of this. So we've got our shopping list class, but now it's been implemented as a piece of client-side code using jQuery and JavaScript. But we've also got a client test project here, and that's just a normal web project, except we've added quite a few JavaScript files. We've added jQuery, we've got this app.js which starts everything up. We've got a view model class, so we've got a very simple view model pattern going on. We've got a test HTML file, which amongst other things, we've got to just note this meta refresh tag, which we're going to use, which is going to refresh itself every 5 seconds. And we've loaded up the view model.js, app.js, and also a library called QUnit.js, as well as another library called jQuery mockjax, which is a tool for intercepting REST calls and injecting our own responses to them so that we can run tests without actually having to go back to SharePoint. So it's a similar sort of approach that we used before, so we can isolate our code and do unit tests, but also have the option to go right through to SharePoint. So all we do is we open up that HTML file. There's a CSS file as well, so there's QUnit CSS, which I've modified slightly to make that green bar at the top look a little bit larger. So we can start writing a test in here. So we'll same sort of drill as before. We'll say should have correct header, but we can use any string. We can have a fairly descriptive string for the name of the test, and then an anonymous function which is going to contain any setup that we need to do before the test, and then the assertion of the test itself. And the assertion here is we're going to use equal, and then I've used jQuery here, you might notice, in order to select an element, in this case the message element, which is where we're putting all our output, and take the HTML of that. Now, if I was doing this again, I might think in terms of just using plain JavaScript and using the getElementById method rather than depend on jQuery. But if you're a jQuery user, you like jQuery library, then by all means use that. It doesn't really matter which technique you use to get hold of that element. You just want something that you can then do that comparison and see that it contains the string we're looking for, which is H1 shopping list. So that's green, but as soon as I save that file with that new test in, the test runner shows red. So we've just got this HTML file running in a browser that's rendering the test output from QUnit. So now I do a little bit of implementation. It's not a very good implementation. We've just got a view model that returns a great big chunk of HTML. That's probably not the way we're going to end up doing it, but for now we can do it this way just for the purposes of getting the test to pass, and you can see that it works. Now later we'll do a refactoring where we'll probably improve the way that's designed and have data binding with the view model and at an element by element basis and generally improve the structure of the code. But just for now we're just going to do it as simply as possible. That's part of the test-driven development practice. And add another one here, so should have list of bananas, do a bit of cut and paste work to get hold of the output, and we could narrow that down to specific elements if we wanted to as well, or we could do tests against the view model in isolation. So we should isolate the view model and just run tests directly against that. So I'm looking now for a string inside here, so I'll call index of bananas and check that that's not equal to -1. I need to change this to OK. It's a fairly limited range of assertions that we have in QUnit, but of course as long as you've got an OK, which might be called is true in another library, then we can build pretty much any test we want to. So I'm just going to do a bit of tidy up and move these out of the way of these dummy tests that I did earlier. I'll probably delete those in due course. And the test fails, of course, because we have no bananas. So we can fix that very simply by adding it to the output, and in a later refactoring we'll be actually taking the contents of the list, making a REST call, and the view model will then be dependent on the SharePoint list that it's supposed to be rendering. But for now, make that test and make that test pass. Just doing a bit of refactoring of my tests here as well. So we save that. We have an error. Fix the error. That test passes. Still got an error. Keep going. And we're green. And everything's passing. Well, we've been talking about test-driven development, and you can actually extend that approach to the whole of the acceptance test process, which is the longer term thing. It's sort of the once per sprint set of tests that possibly another individual, a tester on the team, might be writing. It uses the same sort of approach, but you look at the system as a whole and you'll be doing end-to-end tests, and this is something that people have tried. Now it requires some development effort to come up with a way of using a framework such as Fitness or there are SpecFlow. There are a few TDD frameworks, and they're trying to help you do things like write tests that have English language descriptions that somebody like a business analyst or even a product owner could write and express their requirements in the form of these tests, which are then automated. I think it's quite an ambitious thing to try and do, and I've not heard of too many people who have been successful in applying that. But as the tooling improves, it might be something that we see more and more looking towards the future. And another future technique, or a fairly recent technique, is approval tests, where rather than building a test for each individual fragment of a string that you've rendered, for example, you just take the whole of the rendered output and do one big test against that and say, I expect that to look exactly like this other object. And it also works with things like, for example, images, or even potentially a screenshot or something like that. But any kind of artifact that your code is generating can be tested as a whole. Make your modifications until you get the desired output, and then you can push a button on the approval test system and say, okay, this is what it should look like, and then lock that in as a sort of a regression test. And this is very much a technique that would be useful if you were trying to build a set of regression tests around some legacy code that didn't have any test coverage. And I see this as a particularly useful thing if you're going into some sort of brownfield site which hasn't used test-driven development, but you want to, as a first step, wrap a set of regression tests around the code that you have so that you can lock in the functionality that you've already got, and then you're safe to start refactoring it and making changes to that code without having to worry too much, because you've got the confidence that you've got a good set of regression tests. Another thing which has come out recently is the smart tests, which are available in, I think, the more advanced SKUs of Visual Studio, which has come out of another couple of technology from Microsoft Research. One was called Moles, which was where the Microsoft Fakes comes from, and this is the output of a tool called PEX, which Microsoft Research did. And this sort of analyzes your code and generates sets of test paths that will exercise all the code and give you good test coverage. So again, these are in fairly early stages. There are quite a few new developments that are coming along, and so I think we can expect the testing tools and testing frameworks to improve and make test-driven development even easier as this technology develops in the near future. So just to conclude, test-driven development is continuing to be very popular in the development community as a whole, but for SharePoint developers, it's really challenged us to find ways of testing SharePoint effectively. And to some extent, as we move to more of a new development model of more client-side development or remote development, and treating SharePoint as simply an endpoint, or Office 365 as an endpoint that we're communicating with, this is actually going to make our lives a lot easier, because it's going to be easier to isolate the code under test. We can take advantage of the many frameworks that are being developed in the wider development community and JavaScript frameworks, and we can use a lot of the new techniques as they become available. So I think it's going to get easier to do test-driven development, and I would encourage you to try it out. See whether it's something that you like or that you find helpful. I do, and I would strongly encourage you to try it. So I'll just leave a few bits of recommended reading for you to refer to, and I hope this has been useful and it'll encourage you to have a go, and thanks very much indeed for listening. Thanks.